Okay, this is PreCalc Trig lesson 4.3a, and this is just the remainder of the classroom notes. I'm just going to start off so I catch everyone up just after example 3 in the notes, and it says if a non-quadrantal angle is in standard position, and this is reference angle, let's get something that I can write with. Is defined as the acute angle that is formed by the terminal side and the x-axis. So all of these show a picture of some kind of reference angle. Now the first one, picture 1 here, shows that we have a vertex and an initial side on the x-axis, so that makes it in standard position, and then here's our terminal side. Well, this angle itself, the terminal side already forms an acute angle with the x-axis, so the original angle and the reference angle are really the one and the same. Now on the second picture, again we have an initial side, and then we have an angle that opens up in the positive direction, and it's obviously not an acute angle, but our terminal side does form an acute angle with the x-axis here. So the red one is what's called our reference angle. In the third picture, again we have an angle that's in standard position, and it's going to open up in a positive direction, and it's actually going past 180 degrees. So again, not an acute angle. A reference angle has to be acute. And so we take that terminal side and we form an acute angle with the x-axis. So it really depends where the terminal side is, whether it's going to form an acute angle with the negative side of the x-axis or the positive side. And the fourth picture, another positive angle, clearly way past 180 degrees, past an acute angle. And our terminal side is right here. Now this time it's going to form an acute angle with the positive side. We can't form one with the negative side. So here is our reference angle. So that's what it means to have a reference angle, or the angle that we're going to refer to get the original. Okay, in example 4, I'm going to show you how to use that reference angle to get the original. The original angle is the 315 degree angle. It has an initial side on the positive x-axis. We're going to come around and we're going to go 315 degrees. And what we find is the terminal side forms a 45 degree angle with the x-axis. And we actually know the 6 trig functions for a 45 degree angle. That was in the very beginning of, I think it was the very first lesson we talked about the different trig functions. Because the reference angle is 45, that tells me that the trig functions that we used for that one are going to be the same trig functions that we're going to use for the 300, or the ratios are going to be the same ones that we used for the 315 degrees. The difference is going to be whether the signs are going to be positive or negative. And if you look at the reference angle, you can see that it's in the 4th quadrant, and our terminal side is in the 4th quadrant. And that's going to determine what sign our answers are going to have. The ratios are going to be the same, signs are going to be different. In the 4th quadrant, the x coordinates are positive and the y coordinates are negative. So when we look at the previous statements, when we talked about how the radius and the x and y of the point on the terminal side can give us our trig functions, now we have a positive x and a negative y, and that's going to determine the sign of our number. The first quadrant the x's are all positive and the y's are all positive. In the second quadrant, we have negative x's and positive y's. Let me back that up just a little bit. Our x's are negative and our y's are positive. And then in the third quadrant, we have negative x and negative y. So what does that tell us? Well, our functions, what we had was we had sine of theta is y over r. We had cosine of theta is x over r. And we had tangent of theta was y over x. And then, of course, for the other ones, those are reciprocal functions. And we'll get to those in a moment. I have a phone call. Okay, so for sine, we're going to use our reference angles. And we know that the sine of 45 is the square root of 2 over 2. The cosine is square root of 2 over 2. And tangent is 1, okay, for a 45-degree angle. We actually don't have 45. That was our reference. We actually have 315 degrees. And the 315-degree angle doesn't have all positive x's and positive y's like it does in the first quadrant. It has the x's are positive and the y's are negative. So what that tells me is anything with a y is going to have a negative sign. It says it's going to be actually negative y over r. So that's going to give me a negative square root of 2 over 2. Now for cosine, we see that in the fourth quadrant x is positive, so that one's not going to change. And for the tangent, again, we have a negative y and a positive x. Well, that's going to change the sign of our tangent of 45 to a negative 1. Okay. So that's how we use the reference angle to help us actually get the tangent ratio or the trig ratios. So the reciprocal of sine is cosecant, and so it's going to be it's also going to be negative because it's just r over negative y. So that one is going to be negative square root of 2. And then secant theta is going to be the same, except this time it's going to be square root of 2, but it's going to be positive this time because our x's are positive. And cotangent of theta, that's the reciprocal. Again, we still have a negative y in there, so we're going to have negative 1 for our answer. And those are all now for sine instead of 45, 315. But how they're related is the fact that the reference angle was the 45-degree angle. Okay, for A, B, and C here, it says find the following without using a calculator. What we want to do is graph it and then determine its reference angle and then figure out what we're going to do from there. So this is going to be A. And I'm going to graph negative 210 degrees in standard position. So vertex at 0, 0. Initial side is on the positive x-axis. And this is negative 210. So I have to go clockwise. So I'm going to go past 180 and I'm going to go an extra 30 degrees here. And that's negative 210. But it makes a reference angle, which the terminal side makes an acute angle with the x-axis. It makes a reference angle here, which you can see is 30 degrees past past 180 degrees. Okay, so my reference angle is 30 degrees. So basically, I've got, what I need to know is that in this quadrant where my terminal side is, that my x's are negative and my y's are positive. For A, sine is y over r. R is always going to be positive because it's the hypotenuse, so it's the length there. But we see that in the second quadrant, y is positive. So basically, if I know what the sine of 30 is, that's going to be the same as what the sine of negative 210 degrees is, because the sine isn't going to change. It's still just going to be y over r. The sine of 30 degrees is 1/2. So the sine of negative 210 degrees, which is going to give me the same, is also 1/2. And I could do the same thing for tangent, except this time I'm going to have radians. If it's helpful to rewrite your radians in degrees, you can certainly do that. I know that pi over 3 is equal to 60 degrees, so if I have 5 of those, then 60 times 5 is 300. So this is actually the tangent of 300 degrees. So I'm going to mark B, and there's my standard position. I'm going to come around and I'm going to, 300, it's almost 360. It's a little bit short of that, which gives me a reference angle of 60 degrees, because I'm just 60 degrees short of 360. So my terminal side, which is right here, my terminal side is in the fourth quadrant, which gives me a positive x and a negative y. Well, for tangent of theta is y over x. So I see I'm going to have a negative y. So whatever the tangent of 60 is, I'm actually going to have negative of that instead of the positive. And tangent of 60 is square root of 3. But since 300 degrees, or 5 pi over 3, takes me into the fourth quadrant, and that's where I have a negative y, then the tangent of 5 pi over 3 would equal negative square root of 3. So negative square root of 3 is actually my answer there. We can do the same thing with secant. And honestly, I know it says solve without using a calculator, and I've showed you how to do that with a reference angle, but I would really recommend taking your calculator and just testing that out to see what you get as your answer. And then C, I'll just go ahead and give you the answer to that. Part C, the answer to that one is going to be negative square root of 2. Again, go ahead and use your calculator just to at least check your answer. Don't forget that if you're in degrees, you need to be in degree mode, and if you're using radians, you need to be in radian mode. Okay, number 5 says find each of the following if it exists. If the value is undefined, write undefined. Honestly, you could certainly use your calculator here. But what I would, the other thing that I can do, and you can look at number, or A here, the example of the graph of the sine of negative 270, is that it's a quadrantal angle because, well, it ends up at an axis. Okay, so this is my x and this is my y, and if I solve for r, I would have the square root of x is 0 plus 1 squared, and so that gives me the square root of 1, which is 1. So I've got an r is 1. I know that the sine of negative 270 then is going to be found by taking y over r. Y is 1. and r is 1. So the sine of negative 270 would be 1. You could put that in your calculator and ask it to find the sine of negative 270, and it's going to give you 1. Okay. We can do the same thing with b and find that angle. 3 pi would actually take me so for b, I want the tangent of 3 pi. Again, I could put that in my calculator. If I were to find the angle, if I were to find that angle, I would have to go around 360, and then another, because that's 2 pi, and then another pi would put me here. So it's the same as having an angle of 180 degrees. I could pick a point then on the terminal side, which is over here, of, we'll call this negative 1, 0, where x is negative 1. I would still have a radius of 1 here. Tangent is, back up just a little bit. Tangent is y over x. Y is 0, x is negative 1, so that's going to give me 0 as my answer. Again, if I put that in my calculator, that's what I would get. For c, I have secant of 11 pi over 2. If I graph that, I'm going to rotate basically 990 degrees, and that's 2 3/4 rotation. So I've got 1, 2, and then another 3/4 is what it's going to get. So I'm going to have this terminal side over here. I wonder how much of that I got. Okay, example 6. These are a little sneaky. It says find cosine of theta and tangent of theta. So those are the two ratios I want, cosine and tangent, by using the given information to construct a reference triangle. So I need to make a reference triangle. So let's try 8. I want the sine of 3/7. So we know that the sine of theta is represented by y over r. And then in this case, it says the sine of theta is 3/7. So that means that y is 3 and r is 7. And then it tells me that tangent of theta is less than 0. So that means that it has to be negative. So it's going to be negative something. The ratio for tangent is y over x. Okay. Now I know from sine that y is positive. Okay, that's how I got the positive 3. So in order to get negative y over x, that means that the x would have to be a negative value. So x is less than 0. It's negative. So we have a y is 3 and r is 7. And then we want to know what y or x is, because we want to be able to find cosine, which is x over r, and tangent, which is y over x. So I'm going to kind of try to graph that on my little coordinate plane here. So I have a y that's 3. That means I'm going to go down 3. And my x is negative. So I've got to go far enough over here, and I'm not really sure where that is, so that I have an r, or let's back that up. I didn't mean to draw it that way. Okay, I've got my y goes down to 3. I'm going to get this in a second here. My y goes up to 3. That makes more sense. My x is negative. So somewhere over here in the negative quadrant, or the negative x-axis. And so, I don't know, maybe it's right here. But I know that the radius is 7. So that's going to give me a y that's 3, and then there's going to be my x. So that's where it would have to be drawn in order to get a positive y but a negative x. Because I'm in the second quadrant. So now I'm going to use Pythagorean theorem, but I know that my x is going to end up being negative. So x squared plus 3 squared equals 7 squared. If I subtract 9, I'm going to get x squared equals 40, and then I have to take the square root of both sides. You get x equals the square root of 40, or 2 square root of 10. Now, when I take the square root, it can be positive or negative, and we know in this case that we want a negative x value. So my answer for x is negative 2 square root of 10. So I can go back up here at the top and state that x is equal to negative 2 square root of 10. Now I can find the cosine and tangent, because cosine of theta is x over r, and I have my x is negative 2 square root of 10, and the r is 7. And then I can do the same thing for tangent. Tangent is negative y over x. And so my y is 3. My x is negative 2 square root of 10, and it says that whole thing's negative. Well, two negatives make a positive, so that's actually 3 over 2 square root of 10. Or 3 square root of 10 over 20. You can tell that those are a little bit tougher problems. Okay, I just want to look at B and C really quickly here. B tells me that the secant of theta is equal to 3, and that sine of theta is greater than 0. So that means it's positive. So we've got to use those ratios that we know. I know that secant is the reciprocal of cosine. So secant is r over x, and I know that my secant ratio is 3, so that's 3 over 1, which tells me that r is going to be 3 and x is going to be 1. R is always positive, so that's going to mean that here our x is positive as well. And then it says sine of theta is greater than 0. Well, sine of theta is y over x, and if it's greater than 0, and we already know that x is positive 1, then y also has to be positive. So in order to have a positive x and a positive y, that means that the terminal side has to be in the first quadrant. So what we're really drawing is that reference angle. And I've got x is 1, and y is some positive number, with 3 being the radius. So it's about right in here, okay? And so this is going to be the point 1 something. We don't know, okay? But it's some positive number. Well, I do have r, so I can use our formula for r to solve for y. R is the square root of x squared plus y squared. So 1 squared plus y squared. I do already know what the r is, so we'll replace r with the 3. And simplify, so 3 equals the square root of 1 plus y squared. You want to square both sides. And that's 9. Subtract 1, and so we get y squared equals 8. And then when I take the square root, I know that I want y to be positive, so I'm going to look for the positive form of the square root of 8. And so y equals square root of 8 or 2 square root of 2. So now I have values for r and x and y, and that will allow me to find cosine and tangent. So cosine of theta, which is x over r, would then be 1 over 3. And tangent of theta, which is y over x, would be 2 square root of 2 over 1, or just 2 square root of 2. So you really have to think through those problems in order to get the answer. Okay, the last thing I wanted to do was just kind of go over the different sections that you have to do in your homework, just so everybody knows what's going on. I'm going to assign numbers 1 through 6 all. And you're also going to do 13 through 47, the odds. So for 1 and 2, it says identify the one angle that is not coterminal with all the others. So to be coterminal, it has to be plus or minus 360 degrees of one of the angles. So it's just saying which one's not. If I'm talking about radians, it has to be plus or minus 2 pi. 3 through 6 says evaluate the 6 trig functions of the angle theta. So you're given a point on the terminal side, and those are going to be your x and y, and you'll want to find your r using r equals the square root of x squared plus y squared. And then so once you have your x, your y, and your r, you're going to use those to evaluate the 6 trig functions. Okay, 7 through 11. It says point P is on the terminal side of theta. Evaluate the 6 trig functions. If the function is undefined, write undefined. So again, it's just like 1 through 6, except they don't give you the graph. They just give you the point, which is x and y. So you still want to find r and find out what those 6 trig functions are. 13 and 15, it says state whether it's positive or negative, the sine, cosine, or tangent. So for the interval given. So for 13, that's 0 to pi over 2. Well, that means 0 to 90 degrees, which is the first quadrant. So basically it's asking if you were in the first quadrant of the coordinate plane, what sign would your sine, cosine, and tangent be given? 15 goes from pi to 3 pi over 2. That's the third quadrant. So in the third quadrant is your sine, cosine, and tangent positive or negative? For 17 and 19, you're supposed to do the same thing, determine which, figure out which quadrant it's in, and then whether it's going to be positive or negative. Number 21 and 23, it says choose the point on the terminal side of theta. So if theta is 45 degrees, you want to figure out, based on the points given, which one would be in that same quadrant there, or what would x and y have to be if theta is 45. For 23, 7 pi over 6, you need to determine what the x and y's would have to be for that angle. Um, 25 through 26, it says evaluate without using a calculator. You can go ahead and use one, to be honest. So for 25 and 26, we're going to get rid of that part and evaluate using a calculator. You can do that. Number 37, 39, and 41. It says find sine, cosine, and tangent for the given quadrantal angle. So that means it ends up on a reference angle. If you have a reference angle, your ratio is either going to be 1 or -1. 1, -1, 0, or undefined for those. So those are your possibilities for that. And then the last section, that's that tough part. It says evaluate without using a calculator. You want to figure out what sine, so for number 43, you want to figure out what sine of theta is and tangent of theta is, given the information that that cosine of theta is 2/3 and that the cotangent is going to be greater than 0. So to get you started on 43, you have to remember that cosine is equal to x over r. So for this problem, x has to be 2 and r has to be 3. And then you know that your cotangent value, which is y over x, is positive. Well, if x is positive 2 and y over x is positive, then y also has to be positive. So you got to kind of take all that into account. You've got a positive x, you've got a positive y, and you get a positive x and a positive y in the first quadrant. So that should help you draw a reference triangle there and figure out then what sine and tangent are. Okay, happy mathing, and I will see you on Thursday.